right, product property of square roots. Kind of the opposite of what we were just doing. The square root of a product equals the product of the square roots of the factors. Okay, so in so many words, if I have the square root of 9 times 5, this could start off as the square root of 45. It equals the square root of 9 times 5, and then they can be chopped up. Square root of 9 times the square root of 5, which gives me 3 times the square root of 5, because the square root of 9 is 3. Okay, so you can take whatever factors you have and divvy them out like this, where of course these are larger than 0, well, equal to or larger than 0. Okay, quotient property, very similar. So if I have a fraction under a square root symbol, I can chop them up into 2 separate ones and then take the square root with that. So here's the more general term. And again, this stuff that I have is on that sheet that you can print out. And you'll also get one in class if you haven't already gotten one. Sorry, I feel like I'm flying through this stuff, but I know that you've had all this before. Okay, so using those properties that we just learned about, what we want to do when we're simplifying square roots is we're looking for the largest factor that's a perfect square. So what are some perfect squares? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. So here's some perfect squares. So that's what I'm looking for factors in here. Okay, so 24, what is my largest perfect square that goes into 24? Well, it's 4. So this becomes 4 times 6, which is 4 times 6, which is 2 times the square root of 6. Okay, here we have 48. 16 goes into 48. It's 16 times 3. So I have negative, just leave that negative out here. 16 times the square root of 3, and this is negative 4 times the square root of 3. Okay, 162, I'm actually not sure. I'm going to just try a couple. So 162 divided by, let's try 36. Nope. So 162 divided by 64. Nope. 162 divided by 16. Nope. Okay. I'm not sure. Let's see. 162 divided by 2 is 81. So 81, I should have known that too. So this is the square root of 2 times 81. Now here it is with the g to the 6th. I'm going to write this out so that you can see what I'm doing. So I've got 6 of them. 1, 2, 3, 4, 5, 6. Now remember that for every 2 of these, only 1 comes out, right? Because this is like 2 9s. Okay, so this is the square root of 2 times the square root of 81 times the square root of g times g times the square root of g times g times the square root of g times g. This is probably really confusing. I hope not. I'll do the next one a little differently. Okay, so this becomes 9. This becomes g. Okay, this becomes g. And this becomes g. And then we're just left with the square root of 2. So I have 9g to the 3rd times the square root of 2. Now really this is how it works, okay? If I have an even number here, I just divide by 2, and that's what comes out in the front. Because g to the 6th is a perfect square. It's g to the 3rd squared, okay? So over here, I'm going to erase this. Over here, I have negative 512 h to the 7th. And what goes into 512? Let's see. 512 divided by 2 is 256. 256 is 16 goes into that. So 512 divided by 16 is 32. 256, is that, what's 15 squared? 225. 16 squared is 256. So 16 squared. So this is going to be 256 times 2 times, I need to turn this h to the 7th power into a perfect square. So I've got h to the 6th times h. Okay? H to the 6th times h to the 1st is h to the 7th, but I've chopped it up right here. Okay? So now I've got the square root of 256 times the square root of 2 times the square root of h to the 6th times the square root of h. This is a perfect square. It's 16. Okay, so I'm done with that one. This is a perfect square. It's h to the 3rd, because I divide by 2. And then what's left, I could have just kept them together. But that's what I have that's left. Okay. All right. So I want you guys to try these, and I will go over them in the next video.